Hello, hi everyone. This is Prasanna Kumar Lagnani. I am going to come with a lecture series on RAG and RAG architecture and the applications of RAG architecture and how to implement RAG in real-time world, in real-time application. How can we use RAG? So we know that there is a tremendous change in natural language processing with the introduction of large language models. So after heavy utilization of large language models, people came to know that there are some issues with large language models. So, in order to overcome those issues, again, people have introduced a new concept called as RAG. So, now in the industry, the buzzword is RAG architectures. So, what is a RAG? RAG is a retrieval augmented generation. What is the purpose of RAG? Where we can use the RAG? What are the different applications of RAG? So these things we will learn through this video lecture series. So in this video, I am going to explain you about from basics to advanced concepts of RAG. Especially in this video, I'll introduce what is the RAG, what are the components of RAG, why we need to go for RAG, and what is the RAG pipeline, and what are the things required in order to build up the RAG, and what is the drawbacks of LLM and how we can overcome those drawbacks with the help of RAG architectures. So today we will cover the introduction of RAG and the RAG architectures and what is the RAG pipeline, end-to-end RAG pipeline, and advantages and disadvantages of RAG, and building the RAG from scratch, and what is a multi-dimensional RAG or multi-modal RAG, and what is the difference between RAG and fine-tuning, and what are the evaluation matrices of RAG, and how to improve RAG systems, and what are the available research papers in the RAG. So these are the topics which I want to cover in this RAG series. So today in this session, I will explain you what is a RAG. So what is a RAG? RAG, the full form of RAG is Retrieval Augmented Generation. Retrieval Augmented Generation. So it is an architecture used to help the LLM models like GPT, Gemini, Gamma, LL Llama. So there are so many LLM models are there. In order to support, in order to get a qualitative information, qualitative answer from the LLMs, this RAG is helping the LLMs to give a qualitative and exact information and relevant information with the help of additional resources and reduces the chance of hallucination, reduces the chance of incorrect information. So once if you see the definition of RAG, RAG is called Retrieval Augmented Generation. So is a architecture used to help LLM models like GPT-4, Gemini, Gamma, Llama 2, Mistral to provide a better response by using relevant information from additional sources and reduces the chance that LLM will lead to incorrect information. So you people will think that, so why LLM will give the wrong information? LLM have a vast knowledge. LLM is trained on hectic data, heavy data. All LLMs are trained with billions of parameters and almost all the data is in the world. Then why there is a chance of wrong information from the LLM? That I will explain in couple of minutes. So if you see one more definition of RAG is a technique that enhances language model generation by incorporating external knowledge. This is typically done by retrieval relevant information from a large corpus of documents and using that information to inform the generation process. That means RAG is helpful to bring the information from the external sources, external storage devices, databases, and that external data information is supplying to large language models, so that the large language models is taking the response, is giving the response with the help of external knowledge. So this is another definition of RAG. Similarly, with RAG, the LLM is able to leverage knowledge and information that is not necessarily in its weight, means it is not inside the training. Sometimes the LLM may not know all the information. Sometimes we may ask a query which is beyond the LLM's memory. But the main drawback of LLM is, even though it is not updated, even though it doesn't know the latest information, it is trying to give some information. It is trying to answer some information from its memory. That answer may be correct or may not be correct. That means the LLM will never say that I don't know the answer. It tries to give some answer from its memory, even though it does not have the latest information. It is trying to give some information. That is, it is bluffing the query. So whatever query we are, whatever the user query we are asking, whatever the prompt which we are asking to the LLM, it is trying to bluff by giving some relevant answer. That relevant answer may be correct or may not be correct. That is the problem with LLMs. In order to overcome those problems, RAG, Retrieval Augmented Generation architecture were introduced to help LLMs to give a proper response, a correct response, updated required answer from the LLM for the given prompt. Suppose if you see, RAG is one of the hottest and most important topics in generative AI, large language models, AI applications, AI agents, and enterprise systems. So in all these aspects, RAG is a most important, hottest topic in all these concepts. Companies like OpenAI, Google, Microsoft, Meta, they are all heavily depending upon RAG systems. They're all using RAG systems heavily. So that is the importance of RAG. RAG is a technique. With the technique, we can able to get the correct answer. Always you cannot give the answer from your memory. Sometimes you need the external source also. You have to take the external information and you have to apply your memory so that you can give correct response. LLMs have memory. When you ask a query, LLMs will give the answer from its memory. This memory may be updated or may not be updated continuously. Now, if I ask a question to a LLM system, what is the HR policy of a particular company, X company, X company? Now I have trained the LLM before 1 month. before 1 month with my HR policies. Now my company HR policy is changed. Suppose if you ask the LLM, tell me about the HR policy of a company X, it will give you some answer. It will give you some answer, even though it doesn't know the updated version of the HR policy. So now, what happens in this case? We are getting incorrect information about HR policy of that company. So this is what is called hallucination. What do you mean by hallucination? Even though it doesn't know anything, even it doesn't have the updated information, it is trying to give some answer from its memory and from the previous knowledge it has on the particular information, particular query. So in order to overcome this, retrieval augmented generation concept was evolved. So here, suppose if you are using a chat GPT, if you are asking a question to chat GPT, so what is the latest company policy? So now, but the model was trained before that policy existed. That means the chat GPT was trained before that policy was existed. Then how can it can answer correctly? So this is where RAG comes into the picture. This is the time where RAG comes into the picture to answer such type of information. Now, what is the full form of RAG? What is the full form of RAG? A RAG is a retrieval augmented generation. So RAG is a technique that combines retrieval of external information and generating the response using LLMs. That means it is taking the external information, external knowledge, that knowledge which we are supplying to the LLM. Now we are generating more accurate and updated response. That means your user has given a query, or you can call it as prompt. So according to the prompt, we are retrieving information from external sources. This information, this relevant information according to the query, plus you are giving your prompt. Combinedly. So this is what is called augmented. What will be augmented? Your external information is combined with your prompt, and combinedly you are sending this information to your LLM model. Now LLM, with its experience, with its updated knowledge given by the retriever, it is giving the updated and correct response to the user prompt. So you people may think, sir, why can't we update the LLM? It is very difficult to fine-tune an LLM. LLM cannot be fine-tuned on day-by-day basis, on hours to hours or day-by-day basis, because we need to train billions of parameters. It takes a lot of cost and time to fine-tune every time the LLM. So fine-tuning LLM is very cost. But when it comes with the RAG, it is very much easy to provide the external information as per the query asked by the user, and both are combined and given to the LLM. LLM will process and will give you the correct response to the user query. Suppose we will take a real-time example to understand what is an LLM. What is the difference between LLM and what is the advantage which we are gaining with the help of RAG systems. A student writes an exam only from the memory. Suppose a student is there. He mug ups some matter, he mug up some subjects continuously. Now he has knowledge about the subject. Now if you ask a question, if he knows, he will tell from his memory. If you ask a question which is not there in his memory, he cannot able to answer, or he will answer with incorrect information. So now what I have to do? What I will do? For his memory, I will give him chance to read the external books. External books. Now, for my question, he will use his memory and also he will take the help of the external books. Both he will combine and he will give the correct answer for my prompt. That is where the RAG stands. Memory may be incomplete, outdated, and incorrect. Now, what I have to do? I have to take the external support. That means the student is allowed to open the textbook. Now, he will note down, he will search the information, collect the information, and he will answer to my question. That means his memory plus open the book to search the relevant information, both he has combined and he is trying to answer the exact required information to the prompt. That is where the RAG stands for. I think you are understanding. So why do we need RAG? To avoid hallucination. Hallucination is a very, very important problem or drawback with the LLMs. So, in order to avoid hallucination, we need the RAG system. LLMs sometimes generate the fake information because it doesn't know the updated information, but it won't say it won't say that I don't know the information. It will feel shy if it says I don't know the information. It tries to generate something according to our prompt. So due to this, it is generating fake facts, it is generating fake citations, it is generating wrong answers. So to avoid this, we need RAG. We need RAG. Next, outdated knowledge. Models are trained on old data. Every day we cannot train the data. Every day we cannot train the model because it is very costly effective. You cannot train billions of parameters every day. So every 4 months or every 6 months, once in a year, we will train the models. So that's why model has an outdated data. So that's why what happens? It doesn't know the latest news. It doesn't have the latest company data. It doesn't have latest research. So now this problem can be overcome by using the RAG systems. Next, no private knowledge. The most drawback of the LLM is it doesn't have the private information about a person or about a bank or about any company. So how we are training the LLM? We are training the LLMs with the publicly available data. We are training all LLMs model with the publicly available documents. But no company will give their private information publicly to train into the LLM. Suppose I want to know the HR policy, the leave policy of a particular company. I want to know, I want to know the HR policy or leave policy or leave policy of ABC company. ABC company. ABC company will never release their leave policy or their HR policy into the public domain. Now, if you ask a question about ABC company HR policy to the LLM, what can answer? It cannot answer. It cannot answer properly. It will say something. That is the problem with LLMs. So LLMs do not have companies' documents, hospital records, and university policies are private policies of a company. So these are the major drawbacks of LLM. One is hallucination. That means it won't say that I don't know. It will straight away say some information. Whatever prompt you ask, it is trying to generate some information. We cannot give guarantee that the information or response generated from the LLM is 100% correct. So that is what is called hallucination. Second one is, what is second one? Outdated knowledge. Why it is outdated knowledge? We cannot train the LLMs on daily basis. It is very costly affair. We have to train billions of parameters. You need a lot of computational resources. So it is impossible to train an LLM on daily basis. Now what happens? Definitely LLMs will have an old knowledge, old data. Because of that, LLM doesn't know the latest news, latest company data, and the latest research policies. And LLMs doesn't have the private information, the secret information of a company, of a person, of hospital into the LLM. So how you will train the LLM? We are training the LLMs by using publicly available data, publicly available documents. So no company will keep their private or confidential information or HR policy or salary policy or leave policy into the public domain to train the LLM. So now what happens if I ask the ABC company's leave policy? It cannot tell. Now, to overcome all these things, only one mantra, only one excellent technique was introduced. That is what is called as RAG, Retrieval Augmented Generation. Retrieval means we have to fetch the information from the external data. What is meant by augmented? Whatever the data we have fetched, and you have to combine the data with your prompt or query. Now, we are combinedly giving, we are giving external data, we are giving the external data, and we are giving your prompt combinedly to your LLM. Now, LLM will think, will process, and will provide the correct responses, to the user query. So this is what the information, the advantage of or application of RAG. Suppose if you see the key challenges of traditional LLMs, one is knowledge cutoff. One is knowledge cutoff. Why knowledge cutoff? Always LLMs will have outdated data. And hallucinations. What is hallucination? It is generating some information, whether it have idea or doesn't have the idea. It is trying to give some answer. We can, with confidence, we cannot say that it is exactly the correct information. That is what is called hallucination. And next one is, it doesn't have the domain specific knowledge. And no source attribution. That means traditional LLMs cannot point to where they got their information. Hard to verify. That means we cannot say, hey LLM, where you got this information? You have given some answer to me. Where you got? It cannot give the exact answer. It lacks deep expertise in specialized domains like company data, research, internal documents. It doesn't have the domain specific knowledge. So these are the key challenges of LLMs. So these can be addressed. These problems can be solved with the help of RAG architectures. So now, what RAG can solve? Now we have seen what are the problems with LLMs. All problems can be solved by the RAG. So what problems can be solved by RAG? Retrieval external data, use latest information, reduce hallucination, we cannot say that 100% we can reduce the hallucination. Why? Because we have to measure how much of the response is correct. There are so many metrics are there. With those metrics, we will estimate the response is correct or not. So it will reduce the hallucination, and we can also get domain specific questions. That is leave policy of a ABC company, the stock secrets of some X company. So the diabetic patient information from a hospital. So all these are domain specific information. So these domain specific answers can be addressed by RAG architectures. So from this, what you can understand that here I am drawing the RAG architecture, the basic RAG architecture. Here user comes. This is user. User have a query. Now, whenever he has a query, first of all, he searches from the external database. He searches from the external sources. So, what are the external sources? We are storing your data. You are taking the data and you are parsing the data, and you are chunking. That means keeping the data into pieces, and you are storing those chunks into the data store that is called as a vector database. I will explain you what is a vector database in the upcoming videos. That means what is the data pipeline? You are taking the data and you are parsing the data, and finally you are chunking the data. Parsing means you are cleaning the data. You have so many punctuation marks, some irrelevant information in the data that you have to remove. The process called as parsing. Now, after parsing, you are keeping the data into pieces, that is called as chunking. There are a lot of chunking strategies that also I will explain in the upcoming videos. So now I am storing the data into the vector database. Now whenever you are writing a query, that query will be sent to the vector database. Now according to the context, in which context you are asked, you have prompted, you have given the query. As per the context, it will take the similar information. Here we will use similarity measures like cosine distance in order to measure in order to compare what is the user query and what is the relevant information is there from the vector databases. So now, as per the context, it will retrieve the data. Now, this information plus your query will be sent to the LLM. This LLM will process the external information and it will compare, it will take the query and it will do the process and it will give you the response. This is what the architecture of RAG. So here, where is retrieval, where is augmented, where is generation? The retrieval means here the query will be sent to the database. So now the query context will be compared and we will bring the context related information as per the query. Now this information and this query will be combined. This process is called as augmentation. Now both your context information and your query will be sent to the LLM. Now LLM will generate your response your LLM will generate the response as per the query and the external resources. So this is information will be more accurate, more updated, and it reduces. So whatever the response you are getting from this LLM will be less in hallucination and updated, more updated, and finally more accurate information. So this is the complete architecture of RAG. So user query, that prompt will be sent as a context to the vector databases. According to the context of the query, information will be retrieved from the vector database. That external information, that means that context and your query will be combinedly sent to the LLM. Now the LLM will process and will give you the exact response. We cannot say that 100% response, correct response. We can say that more accurate, more updated, less hallucinated information. This is what the importance of that. Here we can see the phases of RAG. Here we can see the phases of RAG. Here I am going to explain the phases of RAG. So phase 1. Here phase 1. This is phase 1. Here data ingestion pipeline. That means this is an offline process. This happens before the collection of data, before applying your query to the database. So here data collection. The system ingests data from various sources. You are collecting the data from various sources like PDF, Word files, web pages, API, databases, internal documents, research papers. Like that, we are collecting the data from various resources. So after that, we are text chunking. That means we cannot give the large document as it is. We are chunking, or we are splitting the large documents into smaller manageable chunks. Typically, every chunk may contain 200 to 1000 tokens. That's why then your response will be qualitative, because it is more efficient to search through smaller pieces. If you give a large document and if your context query is searched with the database, it will be difficult. Suppose if you give a small pieces of query, small pieces of document, then it will be easy to retrieve the context. So LLMs have context window limits. So next, smaller chunks provide more precise retrieval. That means if the document, if the information in the document is in small pieces, so that every small piece have a precise information. So that's why it is a precise retrieval. For example, a 50-page manual might be split into 200 chunks, each representing a specific section or a concept. That means every chunk has a specific information or a specific concept. It is representing some specific concept. After that, we are embedding. What is embedding? Converting the document into embeddings. Embeddings means numerical values. So here, this is where the magic happens. An embedding model. We have so many embedding models like OpenAI, text embedding, Coherence embedding, open source models like sentence bet. There are so many embedding models are there which converts each text into a vector. Each text into a vector. Essentially, a list of numbers. What is a vector? A vector is nothing but a list of numbers. Every word will be converted into embedding called as vector. So, entire natural language processing will deal with vectors. That means every word will be converted into a numerical value. So what are embeddings? Embeddings are numerical representations that capture the semantic meaning of text and the similarity concepts, and we can keep the similar vectors at one place. So similar concepts have similar vector representations even if they use different words. So for example, the customer wants a refund. User requests for a money back. These two sentences would have very similar embedding vectors. That means whatever the vectors which are similar, they will be kept at one place so that when you have a similar set, those vectors will be retrieved. So here in both the sentences, the customer wants a refund, user requests money back. Both are same. So that means even though the words are different, we are treating it as a similar vectors because they express the same concept or same situation, even though they have different words. That is what is called as vector similarity. Vector similarity. Next, finally, vector storage. This is all happening offline before your query context is comparing with the vector database. Before searching, you should have the database. If you don't have the database, where you will search? So you have to keep the database. So how we are preparing the database? This is the way of preparing the database. Vector. All these, whatever the embeddings we have done so far, all these embeddings are stored in a vector database called as vector DB. So here the popular vector DBs are Pinecone, Waviate, ChromeDB, and FiC. These are the famous vector database that's optimized for fast similarity searches. The database indexes these vectors so that you can quickly compare and you can bring the required information. That means after embedding, you have to store all those embedded vectors into a storage called as vector storage. Here, this is just a diagrammatic representation of how the data is prepared offline. One is data collection. That means we are collecting the data from the web, PDFs, various sources from various databases, and we are combinedly collecting and we are sending those data into the text chunking phase. Here it is chunking the text into small pieces. Now every piece we are embedding. Embedding means converting every word into a numerical value. Now here semantic address. Whatever the similar vectors are there, that we are comparing and we are keeping at one place. Now this is your search database, your a search engine. Now after embedding, we are storing all these things into your vector storage. Vectors, that is called as vector database. Here we have indexes. Where are the vectors? What are the indexes? All these things will be stored in the vector database. This is what happened before your retrieval process. After that, the second phase is query process. That means the runtime query process. So this happens when it will be happen when user asks a question. That means your query. This means it is a prompt. When user asks for a prompt, that means user query. A user submits a question. What is the refund policy of defective products? This is my query. Now, this query embedding. That means the exact same embedding model used during injection now converts the user query into a vector within the same dimensions. That means the query will be converted into a vector. Now, because we have to compare the vectors. You are writing the query in English like long ways, in words. You cannot compare your words with the embedded vectors in the vector database. Those are numericals. Your query is in Word. Now what we have to do? We have to convert your query into embedded model, embedded vector, so that it will be easy to compare the context and fetch the similar vectors. Now this consistency is crucial. We must use the same embedding models for both injunction and queries to ensure that the vector space align. That means whatever the embedding technique which you have used in creating the database, the same embedding techniques, embedding models which you have to use to convert the user query into the embedded vector. Then only the similarity will be checked factually and correctly, and you can retrieve the correct context. That is called a similarity search. The system performs a semantic similarity search in the vector database. It compares the query vector against all stored vectors using mathematical distance matrices like cosine similarity, Euclidean distance, dot product, and data, so that it will retrieve the top k queries, k similar chunks from the vector database. So what will be the comparison of vectors? What measures we use? Cosine similarity measures the angle between the vectors. Euclidean distance measures the straight line distance between the vectors. And dot product measures the vectors alignment. So like this, by using these types of vector measures or distance measures, we will find the similar context vectors. The database returns the top k similar chunks. Now these similar chunks information will be sent to the LLM. So context retrieval. The system retrieves the actual text context associated with the top query. That means whatever is the context, and in your search, what are the top k queries, k similarities, those will be called as retrieval context. This becomes a retrieved context that will give augment to the prompt. That we will augment to the prompt. That means it gives the top k queries, k similarities, k top queries. Now this we will augment to your prompt. We will augment to the prompt. So this is what a retrieval phase. Combining these things are called as augmented phase. Now here you can see the pictorial representation of query process. So this is user query. User has a query. Now this query is compared or embedded and compared with your existed database. Your query is converted into embedded vector. Now this embedded vector is compared with the vectors in the vector database. So wherever you find the similarity, you will take the top 5% or top 10% or top 5 to 20 queries, 20 vectors from the vector database. Now these vector sets will be given as a context retrieval with your prompt. So here this is the pages of query processing. That is called as retrieval process, and finally the whatever we have retrieved, whatever the similarity vectors are top k context vectors retrieved, and that we are combining with our prompt. And final space is response generation. So after prompt augmentation, what is prompt augmentation? Already we discussed your similar vectors according to the context of the prompt, and the prompt will be given to the LLMs. The retrieved context, that means the retrieved chunks from the database, the user's original query and instructions for the LLM. Query means it is an instruction to the LLM. So these will be combined and will be given to the query. So here chunk 1, our refine, suppose we have taken the context chunks from the database, like our refund policy states that defective products can be returned within 30 days. To process a refund for defective items, customers must provide proof of purchase. Shipping costs for defective products returns are covered by the company. So these are the context vectors which I have retrieved from the vector database. Now your LLM, now user, what is the user query? What is refund policy of defective products? Now instructions. Answer the user's query based solely on the provided context. If the context does not contain the information, so LLM generation. Now, we cannot directly get the exact information from the vectors. Now, LLMs comes into picture and will give you the exact answer with its own experience. Now, the augmented prompt is sent to the LLM like GPT-4 or GPT-5, Claude, LLMs, Llama, Gemini, etc. The model generates a response that is grounded in the retrieval facts, directly answers the user questions, uses natural conversational language. It will give you the answer in terms of natural language conversation. Can cite specific sources, and finally the response will be delivery. The final response is return to the user, like often with source citations showing which documents have the information came from. That means in the earlier we discussed, when you ask a question to the LLM, it gives an answer, but you cannot know that where you got the answer. Your LLM cannot even answer where it got the answer because it is already trained. Everything is there in its memory. So with the help of its memory, it is able to answer, but it doesn't know where, in which document, from where it has given the answer. But in this retrieval augmented generation, the LLM is able to give answer to the prompt with the help of the vectors, and also it will give the source of information from which document it has given the response. So that is where the RAG helps the LLM to be prompt to give the correct exact information or most exact information for the given user prompt. So this is what the response generating by the LLM. So whatever the retrieval context is there and whatever the user query is there, both we are augmenting. That that means your question, user query means it is an instruction. Both are sent to your mind. Your mind is in your LLM. Now LLM will generate the final response. Hello. That means it is giving some information and it is saying that this information I am giving from so and so sources. From so and so sources. That means it is saying that I am giving an accurate information, not blindly. With the help of these sources, these citations, I am giving the information. So that is where the RAG pushing the LLMs to give more accurate and to stand in the natural language processing. So best practices, here I am telling you the best practice of implementing RAG. So here start with the quality data, because the quality data in the vector database is very important. Clean well-structured documents produce better results. And choose right chunk size so that you can get the exact correct context vectors. Use the same embedding models. That means whatever the embedding models which we are using to convert your raw data into the vector database, the same one which you have to convert your prompt into the vector model, or you can convert the embedded vector. That means consistency between ingestion and a query is crucial. That means both the embedding model should be equal. Implement monitoring. That means track retrieval quality and response accuracy. This we have to measure. This I will tell you how to measure the retrieval quality. Add metadata filtering. Filters by date, source, category before semantic search. Before semantic search. Test different retrieval strategies. Do you want top K context queries? Or is there any threshold based information? Or do you use any maximum marginal relevance? These are the different strategies to get the context related vectors from the vector database. So these all place the quality of implementing the RAG. Optimize your use case. Customer support needs different tuning than research applications. Customer asks different queries in different ways. You have to operate. You have to answer the questions. See, this is the best implementations of RAG. Here, there are lot of popular RAG frameworks are there. One is LangChain. Second one is Llama Index, Haystack, Semantic Kernel, and Autogen. These are the famous RAG frameworks, or we can call it as a tools to support your LLM application. That we will discuss all these things in upcoming videos. One by one we will take and we will implement, and we will know what is the importance of each framework. I'll explain all the things practically in the next upcoming videos. Here in this video, I'm going to explain what is the main purpose of RAG. So now, here you can see retrieval augmented. In this figure, you can observe the retrieval augmented generation. So what is meant by retrieval? Your database. From database, this is your query. This is your query. User has given a query. You're converting your query into embedding model. So whatever the documents you are taking, to encode that document, you are using some model. The same model which you have to use to encode your query. Both models should be same. Now, this embedding model, what the vectors embedded by using embedding model will be indexed in vector database. Now, this query will check for the similar with this query. We'll see for similar vectors. Those similar documents. That means the context according to the query, and your query will be sent as a prompt to your LLM. Now LLM will take the exact decision that is called as your response. Your response and the reasons or the documents or citations for your response. This is what is called as generation. So this picture explains you how retrieval is happening, what is augmented, and what is generation. So with this image, I want to conclude that retrieval augmented generation is an excellent technique to support the LLMs, to improve the responses from the LLMs, and to implement privately in companies. We cannot give our private data to the made it public. We cannot give our private data, our secure data into the public market and make LLMs to tune on the data. And LLMs cannot be tuned every time frequently. So that we can address all these issues, hallucination issue, no updated information issue, and exact response issue can be addressed with this RAG. In the next coming sessions, I will explain you the data ingestion pipeline. What is the data? What is meant by parsing? How this parsing data can be chunked? What are the different chunking strategies? And finally, how to embed? What are the different embedding models? and how to store in vector database. And also I will prepare vector database videos also. So please keep on watching my video. I am trying to take more time to give the clear idea, clear understanding about the concept. Always I'll say that my videos are lengthy. See, if you want to learn perfectly, you should understand every concept. Then only you can apply the things into the real-time application. So that be patient while listening the video, enjoy the video, learn more things from my videos, and please keep on watching the future videos also. Thank you. Thank you for watching all my videos.